Welcome to qnawire.
In order to calculate the magnitude in the context of physics, we're going to refer to as the magnitude will be the size of a vector. So in one dimension, it is quite straightforward. The size of the vector is directly the absolute value of the vector. So for example, if we have a vector in one dimension that is -5 on the x direction, so on the y-axis, the size of this vector is going to be equal to 5. This is going to be the magnitude of that vector. In two dimensions, what we're going to have is that the size of the vector now is going to become into the square root of the components squared as in Pythagoras theorem. This comes from the fact that whenever we have a vector in a 2D plane, x and y, what is going to happen is that the size of this vector makes a right triangle where we can identify, let's call this vector v, we can identify the x component and the y component of the vector. So the size is going to be directly Pythagoras theorem. And lastly, whenever we have a 3D vector, then the size is going to be the sum of all of the squares of each of the components, plus by squared plus bz squared, and all within the square root. So for example, just to show how it is done for a 3D vector, let's say that we have a certain vector b that is going to be equal to -3 on I, plus 5 on j, -1 in z. Then the size of the vector is going to be equal to -3 squared plus 5 squared plus -1 squared. Oops. Put this line a little bit more straight. So this is going to become the square root of 9 plus 25 plus 1. So 35. The size of this vector, just reducing the result, is going to be equal to a square root of 7 times the square root of 5. Which you can compute directly in any calculator. This is square root of 35, it's the same thing. So in this case, the size of the vector would be 5.91608. The units are going to be depending on what type of vector you're going to have, right? What is the coordinate axis that you're employing. So with that, it would be all. Thank you very much and have a good one.